Hello and welcome to session 287 in the AISafety.com reading group. Tonight we'll be discussing part of the Existential Risk Persuasion tournament by Philip E. Tetlock and others. The article has been written by many people. I'm just singling out Philip E. Tetlock because he is one of the founders of the field of super forecasting and the front figure of the Forecasting Research Institute. This report was one that was published in July and is on a whopping 754 pages, and it does in fact have many things that we are not going to focus on. We are only focusing on 12 specific pages where we are talking about only existential risk from AI, only the short timelines, and we are only talking about the arguments for a low X risk that the super forecasters presented. So the Existential Risk Persuasion tournament was recently highlighted by Open Philanthropy as something they believe is the best recent challenge to their AI worldview, and that certainly caught my attention because this is like a very strong claim. So the Existential Risk Persuasion tournament was organized by the Forecasting Research Institute back in 2022 and involved bringing together 89 super forecasters, which are people who have demonstrated that they are very good at predicting short-run questions and trying to put them together with domain experts, in particular 32 AI experts, and also other kind of existential risk had other kind of experts. Of course, getting a lot of AI experts to do a lot of work for you is really hard because these are very busy people, and I think like a lot of them didn't appear to know very much about AI X risk in particular, and some of them even appeared to there was one guy who said he had spent less than 10 hours talking about it and was extremely optimistic about AI X risk, and feels kind of silly to call someone an expert if they haven't thought 10 hours about a specific subject. And also they asked the public, only those with college graduates, so that's like also an attempt to get more qualified. So what they actually wanted to do is to incentivize like good forecasts, of course, and good explanations, persuasion, that's in the name, and getting people to actually update. And Philip Tetlock and the others designed a tournament with 4 stages, and it seemed like a rather intricate subject. And of course, the classic problem is that you can't predict. Well, if you predict that we are all going to die, then you're never going to collect the prize, right? So instead, they scored based on like how good were people at predicting what other people thought, and this seems like it optimizes more for like groupthink. So I think that is a questionable way around this problem, but I don't really have a better one. They also had some sub prizes, like the best like argument for something earned, the 10 best arguments earned $1,000, and the 10 best like comments on other people's arguments also earned quite a bit of money. One thing they did not do, which I was very surprised about, was to like say who won, like publish the winner, say, okay, this guy actually won this tournament. That seems like what, like if I were to join this kind of tournament, like I probably wouldn't care very much about winning these prizes because they're very low compared to like what you can earn as an AI expert. But the recognition would in fact be really valuable, and also like if my comment won a prize or something like that, I would really want that to be published. And I think it's really strange that this is not published in any kind of way. So before they actually did the prediction tournament, they made predictions about what are potential problems with this. And one of them was that, okay, if you're an expert in AI X risk, then probably you think like you're biased towards thinking that AIX risk is a big deal. And I think like this is obviously right? This is obviously something that is not just for AIX risk, but for literally everything. Like that doesn't make it wrong. I think it is in fact true, but I also feel like if you are reading an interview with someone who is an expert on the glaciers in Himalaya or something, then yeah, you obviously expect that expert to say that this is actually really important, so it feels priced in some sense. The other thing is that this is actually quite different from what super forecasters are normally doing, like evaluating X risk, mostly because there's less data and it's longer term predictions. I think this is in fact not true, and I think the errors that the super forecasters are making are not of this kind very much. There was also like some problems with the actually running it. 90% of the super forecasters dropped out, and more than half of the experts dropped out. That's substantial. That makes the results somewhat less statistically valid. But I think, like, if the actual conclusions end up being that persuasion is just hard, then having people give up halfway is also a strong signal in that direction. So, the conclusion from the X-Risk Persuasion tournament can be summed up with the sentence that there was large-scale disagreement and minimal convergence of beliefs, which is, of course, sad. Like, the Allman agreement theorem predicts something else, so that's really sad. There's a silver lining in the sense that the super forecasters are well enough calibrated to realize that if there's a 3% probability of extinction, well, then probably we should, have some more resources dedicated to this. But that's mostly in the long term. When they asked the public, they tried to ask in two different ways, and one of them got like a 5% chance of extinction, and the other one got 1 in 40 million. I think this is a classic example of someone not having any kind of model and just pulling numbers out of a dark place.
Wait, you mean like the average result for AIX risk, if asked in a particular way,
Yeah,
actually was 1 in 40 million?
yeah. You could ask if
Huh.
you primed the college graduates with a number of like other examples of like odds and things with very low odds, then they say, oh, then AIX risk is 1 in 40 million. And if you just ask them like, what's the probability that AI will kill us all, then they said, maybe 5%. So I think there is a strong case to be made here that if you ask the public basically doesn't have any idea about this at all, unfortunately. Another thing that was notable was that the risk estimates that AI experts had depended very strongly on how long time they had spent thinking about AI risk. Like the more you think about it, the more worried you get, or the other way around. That if you start thinking about it and then you realize it's not a problem, then you stop thinking about it. But there was a really strong correlation here. In general, the authors are confused. Like, after talking for months and exchanging millions of words, why don't people like converge very much? And I think this noticing confusion is a rationalist virtue. I'm very happy about this. I think some of the disagreements on like how some of the shorter term forecasts, I think I was a bit confused here. That they say that there's a big disagreement in one group says 156 million and the other says 100 million, and this is in my mind basically the same number, 156 millions and 100 million. But again, this isn't a really interesting point. A more interesting point is like, why did we fail to converge? And one of the key things was that there were different priors. The super forecasters had some priors that said that there needed to be a really, really strong burden of proof before AI X risk argument could be accepted, and the AI experts had some other priors, and there was a lot of people using the inside view and the outside view, and failing to like meaningfully reach a compromise between these two. And the way it actually ended up was that people like stalemated each other and started to tune the other person out, saying they just don't get it basically. And I think this is really sad. And I was hoping that this is the kind of thing that incentives could overcome, just by having stronger incentives than stop people from tuning each other out if you can win a lot of money by persuading that person. And I think the actual incentives were pretty weak, and I think you could just make stronger incentives. And I think that's something they should do. And there were also competing claims about the adaptive capacities of complex social systems. This isn't that relevant for the 2031 forecast that we're focusing on. I found a funny error in the sense that there are also some super forecasters who were explicitly skeptical about AI X risk, and they had a median probability of 5 in a trillion probability of AI X risk. That's the number that's given, but then in the appendix, when I read that, it actually said 500 in a trillion. So there is the two numbers are off by a factor of 100. And so the obvious question you could ask is, okay, one of them is obviously an error. Which one is the error? And I will make the harsh statement that the AI skeptics don't actually meaningfully distinguish between these two numbers. It's not like they are visualizing like how much is a trillion. I think this is purely a status argument. Like when you say to someone that there is a 1 in a trillion chance that you are right, you're basically making a status argument, and the word trillion could be billion, and the sentence would be basically the same thing. Right, let's get into the actual AI extinction risk debate. And first, there is the question of selecting the main question, like what is AI X risk? And fortunately, there is a lot of people who have thought about this, and there's a substantial literature on what precisely is an X risk, because it's more than just extinction. And unfortunately, the authors chose to disregard that and said it's something that kills all people or reduces the global population below 5,000. And like, I would personally prefer Nick Bostrom's definition of X risk, where it's something also that permanently and drastically curtails its potential, because it may be something like if there are still 5,000 people alive in 2030, but they will obviously be dead by 2040. Yeah, that is in fact an AI X risk that has happened at that point. Okay, so what are the actual predictions? Here you can see them in all their glory, or a small excerpt of them. The super forecasters predict that before 2031, there is like 1 in a million in the first stage of the Persuasion tournament, and then in the fourth stage after, there was an unchanged probability, and in fact the standard deviation had fallen substantially, indicating that the persuasion by the AI domain expert was counterproductive. And I think this is something that really confuses me. Like, how can you have some arguments that are very different from someone else, and then they try to argue, and then you get even more certain of your arguments? That's like a strange thing to have happen. The arguments that are presented are given in footnotes in a rather odd format, where instead of like attributing quotes to people, they are attributed to groups and anonymized in a really strange way. I think this is odd. I think, like, why was anonymity so important? Like, normally when people go into a tournament, they expect that their performance in the tournament will be like scrutinized. I think that is like it's a really odd thing to focus so much on anonymity, in particular, as I said before, to the point of not publishing the winners or their arguments. Okay, the disagreements fell into 5 categories. The first is timelines. Would there be advanced AI before 2031? Would we have like a fast takeoff? Would there be misalignment? Would we give power to advanced AI? And would the AI be able to kill us? And of course, we are not focusing on all of this. We're just focusing on the sources of disagreement and like where is it before 2031. So on the timelines, the argument was that there have previously been some predictions on when how advanced AI would be at certain times that had been over optimistic. Like we've had AI winters, and I think this is in general a bad argument because the people who are making the timelines are very well aware that there have previously been failed predictions. I think some of the predictions we are seeing are made by people who have strong financial incentives. Like if you've got $1 billion from the stock market to build advanced AI, then probably you are more optimistic because you have just been given $1 billion. I think that's like a reasonable argument that could have been made, but is not made here. Another argument was that Kurzweil, he predicted that we would have AGI, and that didn't pan out. And so, like, I have a previous video on this channel where I very roughly criticized Kurzweil because I feel his arguments are just not very good. But on the other hand, I must defend him at this point because he said we would have AGI by 2029, and it is in fact too early to say that it didn't pan out. Like, I think there is in fact a substantial chance that Kurzweil will turn out to be right, but not for the reasons that he gave. Another thing is that like we're currently seeing scaling, and it's possible that this scaling, in order to continue, will need some kind of novel breakthroughs. And I think it's true there may be, and we also may get breakthroughs. There's a lot of people actually doing AI research right now. There was a meta description, not an argument, was that optimists questioned whether it would in fact be possible to like build a machine that thinks like a human, whether we would be able to do that. And they didn't print the argument, and I've like seen a number of people try to make this argument, and they are usually just horribly bad. So I think the reason why they didn't print it was probably that the arguments for why AGI would turn out to be impossible are just really poor. So let me instead try to give like the obvious timelines argument. Like this is my version, so it's like slightly more formal, slightly more precise than what is normally given, but the basic argument I think is one that is intuitively really obvious, but I'm trying to make it slightly more formal here. And so when you're graphing timelines, obviously you have the x-axis, which is time, and some kind of capability on the y-axis. And the way I define capability is on Bostrom's 6 strategic cognitive tasks, which are intelligence amplification, hacking, strategizing, economic productivity, social manipulation, and technological development. And we're talking here about like how good is a model at these things in like in a sort of best case scenario where you are allowed to ask the model several times like what is like a good way to do this, and you are allowed to have like scaffolding and good prompts and things like that. What is like the best case output of a model? And then you compare with humans, also like the same kind of best where human performance have something like mean 100 and standard deviation 15, and this capability metric, like I call it IQ with scare quotes always. It's obviously not the same kind of thing as IQ, but there is a strong intuitive connection to what people normally call IQ. So if we try to go to timelines, in 2018 we had the original GPT-1, and I must admit I've never actually used the original GPT-1. I have seen it, I have seen some excerpts, and it seems like it's like really stupid. It can obviously make some sentences that make some kind of sense, but like the IQ is like very bad. GPT-2 in 2019 seems retarded in the sense that this is totally a model that's not going to be able to take over the world. GPT-3 seems like comparable to most people. Like obviously many of us live in a bubble at university levels where we are interacting with people who are substantially above the mean, but I think like roughly an IQ of 100 makes sense for GPT-3. GPT 3.5 is substantially better, maybe 120, like the people people who are like at the university level or something like that on average. GPT-4 seems substantially smarter. I would give it an IQ of 135. Again, these are really, really rough numbers, and people who have interacted with this will have different assumptions. But we can try to graph this. So let's try to graph this. So an IQ of 50 in 2018, and then we like just continue. This is like what the graph looks like right now, and of course we continue the graph until 2031. And so obviously these are numbers that needs to be taken with a really, really large grain of salt. This kind of prediction that we'll have AIs with an IQ of 260 at this point is like very vague, but also like 260 is really, really scary in the sense that this is clearly something that is smarter than any human alive today. This seems like the kind of linear forecasting that is really, really simple. Like obviously the super forecasters have access to the same data, and this kind of linear forecasting is something that like to my mind, this is the thing that super forecasters really, really excel at. And so this is an argument that they basically did not engage with at all. And I think this is a core part of my confusion in this, is that the super forecasters didn't seem to be using any model that was anything like this. And that's obviously not because they're incapable of doing this, more likely that there are substantial problems with this experiment. Another timeline issue is that they highlight Eliezer Yudkowsky and say that we should discount his prediction that AGI will arrive soon. And if people have actually been reading what Eliezer Yudkowsky say, then he keeps saying that he is really, really uncertain about the timelines. Like he is really, really not making this prediction. And I think it's kind of strange that this really obvious error was not caught. It's also stated that Eliezer is extremely overconfident. Like, I think I would challenge that in that you can just go to Metaculus and see his calibration, and he gets a B-, which is like not perfect, but also not what people would normally call extremely overconfident. He has a track record of incorrect predictions. There's some people who have tried to argue this. Like there's this post on effective altruism where people make this claim. And if you actually read the claims that Eliezer is supposed to have predicted wrong, a lot of them are like very, very questionable, and it's really, really poorly written and poorly argued. Like I'm sure some people believe it, but this kind of text is not sufficient to claim that Eliezer Yudkowsky makes many incorrect predictions. Okay, that was the timelines. Next is that AI development may be slowed or even reversed by attacks on vulnerabilities. And I think like AI research doesn't, as far as I know, like AI research has obviously never gone backwards. And I think like research very rarely goes backwards. Sometimes maybe people start to I think maybe you could find some examples where like in the dark ages perhaps, where research went backwards, but in general research goes forward. And some of the people who could stop AI systems are like protesters, hackers, crypto miners, criminals, other AI systems, and nation states. And of these actors, like we are trying to like look at broad pictures, like this timeline graph I just showed. And I think this is, in order to have some kind of effect on that, we need something that sets AI research back several years. And I think like crypto miners are not going to monopolize GPUs to the extent that there won't be anyone able to do meaningful AI research for 5 years. Like that's obviously not going to happen. Nation states could do this, and I think it's worth worth singling out nation states as something that could stop this. And the kind of vulnerabilities that are shown, like poisoning data inputs and sabotage, is also a thing that, to my mind, yeah, sure, you could sabotage an AI system, but you're not going to use sabotage to like set the AI field back 5 years. That's not going to happen, right? And the way nation states would go about this is very different. Nation states, if they wanted to shut down OpenAI, they could totally do that, but they would not be using these kind of things. And I think in general, the arguments that are shown here are things that, yeah, they could happen, but I have a really hard time seeing how they could sum up to like the 99.99999 certainty that the super forecasters are displaying. Then there's the AI FOOM debate. And this is basically the arguments that's presented, and like I don't even want to go through it. This is a really, really low intellectual level. There has been written so much about the AI FOOM intelligence explosion thesis, and I think this is just sad to read this basically. And it's not really necessary in a strong sense. Like we could have AI doom and AI X risk very easily without FOOM, and I think like in order to argue for substantially higher than 1 in a million, you really don't need to bring up FOOM. Then there's misalignment, where it's claimed that, yeah, AI safety and alignment will continue to develop, and that could mitigate risks. That is true. In particular, the non-X risk alignment is continuing strongly and going strong. And I think that is something that is easy to mistake for the actual scalable alignment. And I think one way to update on this is to look at the AI safety research. How optimistic are they? And a lot of them are very pessimistic, and I think that is something that needs to be taken serious in this context. And the super forecasters have some nice ideas for how to solve the problem. We could build fail-safe mechanisms or some other things, and they have some nice proposals, and they will notice that we're not doing this kind of things because we don't think it will work, and that's why we're not doing it. They have other ideas. We could like do differential technological development and not build AI so fast until we know how to align them, and that is true. We could do that, and we're not doing that. And this is an interesting claim here. There's tendency to under-forecast defense in these highly uncertain scenarios without a base rate. I think it's an interesting claim. I would really like to see a source whether this is true. I think that there is in fact something to it, in that when people model these kind of adversarial dynamics, it's hard enough to model one adversarial actor and then like having another one and getting their interactions right is really hard. Like I have the same intuition, but for me it like kind of goes the other way, in that the AI may have a lot of options that we don't really see. I think it's an interesting argument. I would love to go deeper into that. Another thing is like, will humans give the nuclear weapons to AI? And I think it's kind of sad that this becomes like one of the major locus of the discussion, because this isn't really the central problem at all. And the super forecasters like rightly ask, why would we do that? And the thing that they ought to think further here is that, okay, maybe the reason why this is like a stupid idea is that this is actually not really central, and what we are mostly talking about is like accident risks. And then there's some discussion about whether it's even a good idea to give the AI control over nuclear weapons, and I think you could argue that it is, but I don't think it's important. And again, the arguments come again that if it became a serious risk, then regulation would contain it. But like, we're not doing that, and the reason we're doing this is we can't persuade people, and like this is also what this experiment is showing, that persuasion is just straight up hard. The super forecasters are also saying that, yeah, we could pass laws that say that you're not allowed to build things that could potentially destroy the world, and that is true. And I think again we should note that we are in fact not passing this law, right? We could totally pass a law, but we're not doing it. And it becomes even more explicit when a super forecaster say, I could imagine and hope to see a law which says don't train AIs to optimize humans. And I would also like that, and I would also love to see that, but I noticed that we could totally pass this law today, and we're not doing that. And I think that is a question that the super forecaster needs to grapple with. Finally, are there some ways that advanced AI could cause human extinctions? Well, obviously humans would oppose the attempts to eradicate humanity, and that's like pretty obvious. Like it seems like like a very basic level understanding, and some of the counter arguments that coordination is hard, we may not get warning shots, and AI have many potential sources of advantages. These are things that are like meant to counter this kind of easy, trivial objections from people who haven't read the arguments. There's the argument that AI may seek resources in space rather than on Earth, but like, sure, that may also be very much X risk to us, and like, why wouldn't they also do that on Earth? There are some more claims here. I won't go into the details. I think this is just basically totally confused. So maybe some kind of proofreading would have been helpful. Then there's the question of whether we will get something that is not a literal extinction, but still an X risk by the standard, for instance, by Bostrom's definitions. And that is things where the AI takes control permanently and doesn't bother to kill all the humans. And maybe because some people are living in remote environments, or have built a mine shaft and filled it with canned food or something like that. And these people probably will still be around even after the AI takeover. And like, why would the AI care to kill them if they're not a threat? And this is claimed to be a lot harder than just killing 10% of the human population. And I agree, this is just a resolution criteria. The question that's being asked is just bad. But the people who are paying for this, the open philanthropy, for instance, like the case where humans have totally lost power, but there's still a few humans who haven't run out of canned foods. That is a bad outcome, and everybody agrees this is a bad outcome. And I think the super forecasters who are like gamifying this by trying to like give lower probability for X risk because they're actually thinking about this kind of thing is like being intellectually quite dishonest. Philip Tetlock, or the authors of the report, speculate a bit about the relationship between catastrophic and existential risk from AI, because they were the super forecasts were also asked to speculate on catastrophic, like killing 10% of the human population. And I think my personal opinion about this is that by definition, killing everybody involves killing 10%, but you get a very wrong intuition by thinking about catastrophes. The way you could, like, imagine that you are trying to take over the United States. That involves taking over the city of Seattle. But taking over the city of Seattle looks really, really hard. And when you think about like how hard is it to make a coup in the city of Seattle, then you think that is really hard because like the main US government will like crush your coup. This means that like you would think that taking over the entire United States is harder than taking over Seattle, but actually it is easier to take over the entire, almost very, very close to the same thing, because the only way you can take over Seattle is by taking over the entire USA. One thing that, in conclusion, I was very sad to see was a number of really basic reasoning errors from the super forecasters. First is the claim that the combined probability of all the necessary steps occurring is necessarily low, and that is the conjunction fallacy. And in particular, the 5 steps that are outlined are very correlated, and they aren't really strictly required. And that means that if you just find the probability of each of them and then multiply them, then you will get a really, really wrong number. Another argument is that AI risk experts are probably overestimating the risk because they are all working for the companies building AI. And I think that should be an argument for why they are underestimating risk, not why they are overestimating risk. The AI experts who are giving timelines say that they are quite uncertain about their timelines, and for that reason we should update to longer timelines. And I think that's just straight up not how predictions work. And like this is just basically an error. Then there's a talk about strong AI. That seems like strong, like conscious AI capable of quality and things like that. That seems like it will require breakthrough, and is that a required thing? And I think this is just a trivial misunderstanding. Like, we don't care about whether the AI has qualia, we care about whether the AI kills us all. And finally, there's the claim that things that have never happened before should have such a low prior that the inside view can be safely disregarded. This is actually me putting words in their mouth, because they're not actually literally saying that, but it feels very strongly like this is what they are saying. That and it seems very clear that they have in fact been tuning out a lot of the inside view arguments. And like, this is always fallacious reasoning, and I'm very curious and saddened to see that these kind of basic reasoning errors have not been caught. So that's one way of looking at the limitations of this study. Another is by looking at, okay, 1 in a million, what is that actually? Like Wait But Why have a poster that you can buy that contains a million dots, and then one of them is red, and then you can try to see if you can find that. Like 1 in a million is in fact a lot. And there was people who said like 1 in a trillion, and the like 1 in a trillion is just means that they basically don't take the question seriously. So the median has a p-doom of like very, very low, 1 in a million. And if you imagine you have a career with 80,000 hours and you spend 5 minutes evaluating a prediction, then you can evaluate 1 million predictions. So if you imagine that you have to spend your entire career evaluating predictions, you have 5 minutes for each prediction, and you expect to make 1 error throughout your entire career. What kind of statements can you be so incredibly confident in? That's a good question. And I thought about this. Like, I think it helps a lot if there is a proof of impossibility. Like, if someone comes to you with a perpetual motion machine, then this is the kind of thing you can reject and be very, very sure. If someone comes to you with a way to do faster than light travel, yeah, that seems really hard. Another thing is if you know of extremely careful counter-arguments. Like if someone says, actually we don't need quantum mechanics, classical physics is sufficient. Then I think the counter-arguments are so strong and so carefully developed that I would assign this also 1 in a million of being true. I think also like many mathematical claims have been scrutinized to an extent where I would also give them claims like this. Like for instance, someone comes to you and say, actually Gödel's impossibility theorem is incompleteness theorem is wrong. Then I say, yeah, you're wrong, and I would assign like 1 in a million to you being wrong, to you being right that Gödel was wrong. Another kind of claim where you can be so incredibly sure are claims that don't have an inside view. Russell's teapot would be an example. If you claim that there's an invisible rotating teapot in between Earth and Venus or something like that, then if you don't have like an inside view on who put that there, then probably this is the kind of statement that is very unlikely to be true. If you're saying the sun won't rise tomorrow without giving any kind of arguments, yeah, that's also probably wrong. I think perhaps if you have claims that only have really, really crazy proponents, phantom time would be an example, that actually the world is controlled by lizard people. This kind of thing I think may also be possible to reject with the strength of, like, this is 1 in a million of being true. But of course AIX risk isn't like this at all. Like the simple linear extrapolation that I showed is like a key part of the argument. The arguments have been made really carefully by Nick Bostrom, and there's a lot of engagement with skeptics, and there are some really high status proponents of AIX risk. So I think basically my final claim on this is that it's impossible to defend a claim like 1 in a million. that is all for today. Thank you and see you next time.